begin with the, we already have done four experiments, and today we will do the fifth and sixth experiment. And okay, now your fifth experiment is to just I have to make a full screen. And, okay, yes. Today we will do the detection of the discontinuities in the form of points, line, or edges. So there are these three are the different procedures, and however the steps are very similar to all of the above. And the first one is in order to detect the discontinuities in a figure. First, you need to convert an colored image. If you have a colored image, then you need to convert into a grayscale image, as usual we are doing in all other procedures. Even we are talking about the histogram equalization, even talking about the arithmetic and logical operation, etc. In every operation, we need to convert the RGB image into the grayscale image. That is always be a first and second step. And then third, you need to detect the edges. And please note that in this experiments, we are more interested in the edges because this is one of the most complicated and which includes the points as well as the lines. So here we will discuss about the pivot and the Sobel operators. These two operators, which are uh, which are extensively used for the detection of the edges and display. And the last step is display all the images on a single on a single plane. So hopefully you understand the task and how. Okay, that is in form of a flowchart. And in order to read the RGB image, you can use the command im read. You can use the command im read, and hopefully it is very clear to you all. Then, in order to convert the RGB image into the grayscale form, then you can use RGB to is a numeric and gray command. RGB to gray command. And next, there are two instructions which will be added for the pivot and the Sobel operator that I will discuss in the programming part. And then next, you have to display all the inputs on a subplot. And in order to do that, you need to use a subplot command. And here we will do step by step. And first, you have to read an image and put into any variable, and you can use e, n, x, y, z, a, b, whatever you want. And then if you want to display this particular image, then you can use it subplot command. Subplot command, it is, I already told you, 2 by 2 means there are four figures you can display on a single plane. And this one is you have to use this command IMShow. IMShow to represent image onto that particular subplot, and you can also give the title if you want. So this is the title and within the this column. And next is you need to convert this e variable in which you have put this input figure, and you need to convert into a grayscale form, RGB to gray. Then it will save into the I. And if you will use the E, then it will update the image. If you are using I, then it means there is a new variable. Means E will retain your actual image will retain in E variable, and your grayscale image will retain in I. And if you want to display this particular image, then you can use this subplot, and this is you want to display it on a second. And then I'm show me you need to show it on a second plane and you can give the title. So there is two important commands if you want to detect the edges that exist within that particular image. Then you can use Sobel operator and the pivot operator. And please note that these two, if you want to know about these two operators, then you can please refer the theory part. And in short, because we are doing only the practical part, you just have to understand that there are two operators which are commonly being used to detect the edges. And in order to apply this particular operator, you need to use this EDGE command and II where you want to apply this operator. So SOBEL, Sobel. If you want to apply Sobel, then you can use it as Sobel. If you want to apply Previtt, then you can write it as a PREVITT, and then close the round bracket, and then you can display the Sobel image on a third plane, and that is so show the command and title. And similar, you can show this Previtt image, Previtt H detected image at the fourth plane. So once you have done all this part, then your output figure will look like this. So this one is your colored image that is referred to as a RGB image. And first you have used. Please note that there are only 4 or 5 commands are there which are important to you. First is a IM read, and then there is a just input image, and this next one is a convert the RGB to grayscale. Third command is J equal to edge, and next is a this is edge for the uh, Sobel, and this one for the Previtt. And these 4 commands are important to you. So in the first case, we have just displayed you here colored image, which is referred to the RGB image, and then we have displayed here uh, grayscale image, and next one we have displayed the edge. We have applied the edge Sobel edge operator and display that particular image, and next we have applied the Previtt. And here you can make the comparison between these two figures and which one is give you the best results, but it depends on your application and image. So this is all about how we can apply the edge and Sobel operators. And okay, and if you want to do it on a MATLAB, then again you can do it very easily. And okay, first of all, ध्यान आवाज नहीं करनी. Okay, sorry. Okay, and where we are, we have to display. Okay. Okay. Hopefully, my entire screen is visible to you all. And just wait a second. It is presenting, and hopefully, it is visible to you all. And the next, we have to do the fifth experiment, and in order to do the fifth experiment, you can write the program and whatever I have shown to you in the PPT, and you can, if you want, then you can go to this link and click on fifth experiment, and this is very similar to that one. Okay, you have to select these 20 lines, and you can use this okay, hold for a second. Okay, you can use this okay, and then you can save as that is your fifth experiment EXP. You can use EDGE and experiment. This one is your fifth experiment. Yes, and click. Once you have saved all the experiment, then definitely there is no image agenda is there. So you can use any one of them, and if you want, then we can use this gateway. Gateway.png, and you can replace the other name also. So okay, then this one is the last. Okay, and then you need to click it on a save, and then you have to run this program. And once you have run the program, and your all the height, width, and the bands will display here. Means all the technical specifications for the input images. And here you can just check it out. The what is the difference between all these images? And the first one is a RGB image, and second one is a grayscale image. Third one is a HSOBL, and fourth one is a HPVIT. So you can also you can zoom it if you want. And there is some, okay, yes, you can use a scroll and you can zoom it if you want, and you can just check it out, the details, uh, whatever we have put it here, and how it is made this texture. You can just check it out. Okay, hopefully this experiment is clear to you. If there is any problem, then you can ask the question. Otherwise, I will tell you the fourth, sixth experiment. Okay, there is no any question. Then we will proceed for the next experiment. Uh, okay, we have done this experiment. If you are using this Ajanta image, then your output will look like this. And however, you can use any image. And your your sixth experiment is to perform the different arithmetic operations or logical operations on a digital image processing. So, what are those arithmetic and logical operations are there? Arithmetic means addition, subtraction, etc., and logical operation involves AND or XOR or whatever. And how we can perform it? We can do it in three simple steps. Read the two different images, apply the arithmetical logical operations, and then display all the images on the single plane. And this is algorithm. And okay, there is some problem in this algorithm. Please avoid this algorithm because this is a very clear. That is we need a RGB image, and if you are using grayscale, then you no need to convert into a grayscale form. And please note that please ignore these two steps because these are related to the threshold. So I have just this is the incorrect flow diagram. But yes, if you want to add some operations, then you can add it here. There is a okay. First of all, I have used a marker, and please note that these two are incorrect blocks. You can use it here on in combinations. Apply arithmetic operations. Apply arithmetic and logical operations. And you can please correct this. And now your experiment, how it look like. So you need to read the two images. So the first one is the image. You have put this image into the I variable, and you have put the second image into the B variable. Then you need to use the arithmetic operation. Just hold for a second. Just hold for a second. 1 second. Okay. 1 second. Okay. Let me check if my voice is okay. My voice is audible to you all. Okay, then we will start with the third step. Now the third step is you need to add these two images because you are using add operations. Then you can use add, and it is better if you will try some other operations like difference function, like AND function. AND and add both are performing the same operations. So sorry, not AND, or, because the logical or and add operation. Both are performing same function, and you can. But here we are taking the example of add. So you can use this command I am add. So what do you want to add? You want to add I and B. So you can use these two figures and you can put it into the J. So what's the next? So your entire program has been performed in these three steps. But yes, the next you want to display it, then you can use the subplot. You can use the subplot to represent Tom image on a first plane. Then you can use second plane for to represent a second image, and then you can use the third image, which is a addition image. You can use it on a third plane. So at output, you will get the three images. And here you can just check it out. These are two stamps, and there is first image and there is a second image. And once you have added these two images, then you will get this kind of image. And hopefully, this point is very clear to you all. And one second, just okay. And the next we will perform this on a MATLAB. So we can. Okay, and in order to perform the fifth experiment, you can take it from here. Okay, fifth experiment we have already done, and if you want to apply the sixth, then you can use it. And you can just take this entire program and use the another window, and you can paste it over here. And once you have pasted, there is no any or there are figures are there, because you can use. Okay, that is little bit complicated, because you need a just hold for a second. So please note that because we need a two image, so that you will see the better results. Uh, so Okay, hopefully my screen is now visible to you all. Now I have just put two figures, and which is Jerry and Tom. I have put these actual figures here, and please ignore this particular figure. This is a previous output. And once you have put all the figures onto this folder, then you can just save this image as a experiment 6, and then you can name it as a add. And once you have saved this, then you can run this program. And once you have run this program, there is an error. There is an error in experiment 6, line 6. And here I am using this Z. Okay, okay. Please note that in this there is another one is here. Okay, okay. In this program, I have used one more title. Extract it to the. Okay, once you have uploaded this third one, please note that in this we have just added the another figure Z, and let's see the output. And okay, there is no any error. Yes. Yeah. Okay. Please note that here we have added the two add operations. So here we have added this first add to add first A and B. This one is your I. Please note that this one is your I, and this one is your B. This one is your Z. And in the first, you have added this I and B. Then you have added J and Z. So means you have added all the figures together. All these three figures are together, and you can show it in a fourth plane. So this is the concept in which in this figure we have used. And if there is any problem in this experiment, then please let me know. Otherwise, I will tell you some instructions regarding the experiment. Okay, this is your sixth experiment. We have done till now. We have done 6 experiments, and we are just left with the 4 experiments. And it's better if you will do it at your end. And they are very easy. You just go through it. All the experiments are already given to you, and you can do the practice. And your next part is make a practical file, and you need to submit on a 31st October, or means submit, not need to submit, but you have to upload it on this classroom. So once you have submitted, then we will evaluate it out of 50 marks, and your all information is visible here. And okay, there is one. Okay. Here I have just uploaded this practical file, and this is a one of my student. And however, you can just write it here your name, and hopefully my screen is visible to you all. Okay, yes, you have to write it to your name and ID over here. Yes, and then these are your experiment. You can just write it the page number, and you no need to. You can remove this column, this signature column, because there is no any requirement. But definitely you have to write it your name and ID at the front of the file, and then you need to upload it soft copy on this. And please note that the entire program is very same, because because there is no any change is up to till we have done. But yes, you need to take a screenshot of your program like this. For example, if you are performing this experiment, you have to rename this with your name. For example, A B C. Sorry, there is you need to use the percentage sign first of all, and you can write your name. You can write your name, then you can use another percentage sign where you can write your ID, and next is your experiment. And once you have done this, you can take the screenshot of this entire window like this, and you can paste it, or you can take the screenshot one by one. First you can take the screenshot of a experiment, then you can paste it on your file. And it must be noted that your name and ID must reflect it uh, on this particular program. And if there is any query regarding the file, then please let me know. And please note that I have uploaded all the experiments, and you just have to do the coding part and show me the output. So this is your task. You have to do it. And if there is any question related to the experiment or experiment file, then you can ask me. And in the next week, I have to take some lectures on your pending syllabus of digital image processing, and I will try my best to perform all the rest of experiments uh, by the end of next week. But it must be sure that you have to submitted all the files on or before the 31st of October. Is there any question related to that? Then please you can ask me on a chat box, and or you can ask me directly. Please let me know if there is any question. Okay, Dhananjay and the rest, all of the students, maybe all are aware of that and got the information regarding the lab file submission. And please take it seriously and meet the deadlines timely, so that you will get the maximum marks in your experiment. So it is very easy to score in this. Uh, and there is one more important part. There is a quiz is pending to you. Quiz is generally required to the quiz is required to the quiz marks is basically added to your internal evaluation component. So after this lecture, okay, not today, but yes, on a next week, on a first day of Monday, I will assign you a quiz, and you need to attempt within an hour, and you need to submit it on the same day. And on the basis of that quiz, you will get your internal marks out of 10. And uh, and your final evaluation of our lab experiments will be conducted on a uh, and your final evaluation will be conducted on a 4th or 5th of November. So your entire syllabus or entire file experiments, whatever the pending task, will be completed by the 5th of November. And maybe your exam will start from the 9th of November, and which have been already been informed to you all. And yes, if there is yes, if there is any question, then please let me know. Otherwise, we can end this session. Please. Yes, if there is any question, then please let me know. Okay, okay. No, there is no question. Then please note that now Saksham and Rishabh, you both are required to be stay on this lecture, and the rest can leave the session now. and those who are from Punjab campus and those who are from HP campus, they can stay here so that I can tell them for the major project. Uh, okay, Rishabh, please, Rishabh, are you, Saksham, are you there? Rishabh or Saksham?
Yes, sir. Yes, sir.
Okay, you
Yes,
both
sir.
are there. Then, Saksham, please call the Nikhil so that he can join this class. Actually,
Okay,
he
sir.
earlier he has joined the class, but lately uh, he has left this class. Please call him so that he can join and we can. Okay, now Saksham is already been left.